Hi guys, in this video we're going to talk about dot plots and histograms. When we organize univariate data, we organize the univariate data in frequency tables. And we talked about frequency tables in the previous lesson, and we said frequency tables are tables that include the data points represented in a set and the number of times each data point is repeated. Dot plot is a graphical representation of the data set on the number line and the frequency of each data point by dots. Let's take a look at this example where we have the scores for 20 students on their Algebra 1 test. We're going to try and organize these data points in a frequency table to be able to work with these data better. So to make a frequency table, I'm going to have a table with the value, tally, and frequency. And we can see that the first value that I see is 60, and it's shown once. 63 is shown once. 65 is shown twice. 68 is shown 3 times. 70 is shown 5 times. 72 is shown 3 times. 75 is shown twice. 77 is shown once. And 80 is shown once. So now to make a dot plot, I have a number line going from the smallest value to the highest value. And it's a scaled number line. So what I need to do is to represent each value mentioned in the data set by a dot. So 60 is mentioned twice. That means on number 60, I need 1 dot. 63 is mentioned once. That means I need 1 dot on 63, 2 dots on 65, 3 dots on 68, 5 dots on 70, 72 is 3 dots, 75 is 2 dots, 77 is 1 dot, and 80 is 1 dot. So this is the dot plot for the data set. Now, if we describe this dot plot, we can say that most of the data are in the middle of the dot plot, and the shape is symmetrical, because if you look at most of the data, which is in the middle, the left and the right and the left side of the middle look almost like it's identical. So we can say that this is a symmetrical distribution of the data point, symmetrical distribution. Looking at the shape of this dot plot, and to confirm that this is a symmetrical distribution, if we put these data points in the calculator to find the mean and the median, you will see that the mean in this case is equal to the median. It's the same value, and that value is 70. So when the mean and the median are equal to each other, that means that both of these values are here in the middle of the dot plot, and that we have a symmetrical distribution because the left side is almost identical to the right side. Now, data also can be represented by histogram. An histogram is a graphical representation of an interval frequency table where the intervals from the table are placed on the x-axis and the frequencies for each interval are represented on the y-axis. So another way of representing data along with dot plot is histogram. Now, let's take a look at the same data set that we had in the previous example, but this time let's construct an interval frequency table and then a histogram. So, to construct an interval frequency table, that means that I'm going to have, instead of specific data points, I'm going to have intervals. So in this interval frequency table, I see that the lowest value is 60. So I'm going to make my intervals go by 5. 60 to 64, that's one interval. 65, which is the next number, to 69. 70 to 74. 75 to 79. And 80 to 84. Now, each one of these interval is the same, has the same number of data points. 60, 61, 2, 3, 4. 5 data goes into the first interval, 5 data goes into the second, and each one of these intervals have 5 data points. Now, if this is we have the intervals here. Now, if we look at the values that belong to each interval, the first interval from 60 to 64 has two data frequency. 60 and 63 goes into the first interval. Now we have 5 data points that goes into the second interval from 65 to 69. We have 2 65s and 3 68. So we have 1, 2, 3, 4, 5. And then from 70 to 74, we have 8 data points. We have 5 70s, 2, 3, 4, 5, and we have 372. For the next interval, we have 3 data points. We have 275 and 177. And for the last interval, we just have 1 data point, which is 180. So now that I have my interval frequency table set up, I need to make a histogram. And to make a histogram, I need 2 axes. I need an x-axis and I need a y-axis. The frequency intervals are going to go on the x-axis. And these intervals are going to be placed as bins. Each bin, it's going to represent one interval. So here we have from 60 to 64. So we don't have to have a scale for the x-axis to put these intervals in. Each interval represent a bin. 74, and then 75 to 79, and then 80 to 84. And now on the y-axis, I'm going to represent the frequencies. One thing that we need to pay attention to, since the x-axis doesn't start with 0, I'm going to have to put this symbol to indicate that my bins are going to start at 60, and I'm going to do the same thing if I need to for the y-axis, which at this point I don't need to. So on the frequency here, we're going to have the the numbers going by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for the first bin, we have 2 values. So my bin is going to have that much value. Second bin is going to have 5 values. And these bins has to be attached to each other. 5. Third bin is going to have 8 values. Next bin has 3. And the last one has just 1 value. And this is the histogram for this data set. Now, if you look at the shape of this histogram, again, you'll see that it's almost symmetrical from the middle to the sides. That means that we have a symmetrical distribution represented in dot plot and in a histogram. So this is what you need to know. Data can be represented by a symmetrical distribution, and in this case, the mean is equal to the median, or the mean and the median are very, very, very close to each other. We have distribution where the shape is skewed left, and when I say skewed left, it's because the most of the data are to the right, and the median is in the middle of these data. So the median is going to be here, but it's called skewed because the data has a mean that is somewhere here. So having a skewed data means that a skewed left data means that we have a median that is greater than the mean. And it's called skewed left because the mean is at the left side of the graph. Skewed right, that means that most of the data are to the left side, which means that the median is in the middle of these data, and the mean is going to be to the right of these data. And it's called skewed right because the mean is greater than the median, and it's at the right side of the graph. So again, symmetrical when we have a mean and median that are equal to each other or very close to each other, and the mean and the median are always in the middle of the graph. Skewed left is when we have a median that is greater than the mean, and the tail of this distribution is going to the left. That means that the mean is to the left of these data. Skewed right is when the mean is greater than the median, and the tail of this graph is to the right of the data, where the mean is. And that's how these are the different shapes of the data distribution.